Uh, so is the audio clear?
Yes, sir.
Okay. So the introduction regarding the module 4 I have explained. Did you hear clearly?
Yes, sir.
Okay. Now I am going to present the screen. Afterwards, I am going to ask you whether the screen is, has appeared or not. I am opening the screen. Wind energy screen, wind energy diagram and heading. Is it appearing?
Yes, sir.
Show Pawan.
Yes, sir.
Okay. Right. So this is the renewable energy resource, wind energy. The kinetic energy of the wind flowing is utilized to rotate one rotor and a turbine, which produces the mechanical work, which in turn, when the turbine is connected to the generator generates the electricity. This is a simple arrangement is shown in the figure. So wind turbine or the windmill is a very simple in construction. There is no complication. Only the blade geometry is complicated. Otherwise, the rest of the thing is most simple one. And this technology is not a new one. From many millions of years, in the beginning also, they have used the wind energy for doing some work. Now, engineering as the technology is advanced, so engineering technology advancement is applied to develop the turbine and the blade rotor and the generator for doing efficiently. So this is such arrangement. You look at this diagram. So this you can say, just to read the labels. Blade is there, turbine, rotor is turbine is there, rotor is there, generator is there, and a pillar, motor, then pipe for carrying water from a well. And then water is flowing there, which is labeled as the arrow mark, and the label is indicating water. So water is falling in that overhead tank. So these are the main parts of windmill utilized for lifting the water from the underground and sending that water to the tank, over the tank. Look at the diagram. This is a general application, one particular application. The application may be different, over a tank, or lifting the water, or for supplying the, simply generating the electricity and supplying the electricity to the neighboring consumers or the neighboring places where electricity is consumed. Air can blow in this direction or in this direction. Air direction, air blowing direction. It is again depends upon the design of the blade. One is upwind. This is upwind air, up direction. Upwind is in this direction. This is downward, downwind. Downwind air. Turbine. Downwind air turbine. It depends upon the shape of the wind turbine blade, aerofoil section. Oh. Look at this, and this is rotating, the rotor of the blade, and in this turbine and the generator assembly is there. The generator generates the electricity through that electrical wire. The electricity is taken to the motor. This motor lifts the water pipe for carrying water. This is, see this pipe for carrying water from the well. This is the well. Water is present here. This water is taken like here, and that water through this pump pipe it is sent to the overhead tank. H2O. So this is the water. So water is collected here. This is how it is a simple application of a wind mill. Now let us look into some other points. This wind turbine, such types, already you have studied in the first year elements of mechanical engineering subject. The same thing now I have taken here. Further applications and further details I will go in the next class. Now let us see some of the important points or the characteristics. See, basically, wind possesses kinetic energy as a huge volume of air moves at high speed due to differential of air pressure at any two places on Earth. Pressure differential is caused due to Earth's rotation and by the uneven heating of the Earth's surface by the sun. The strength of wind is proportional to pressure gradient. An ideal wind speed that can be utilized to extract energy lies between a speed of 10 km per hour to 50 km per hour. This is most important. Now I will highlight among this the most important point. Show Pawan. Show Pawan.
Yes, sir.
Is it clear?
Yes, sir. It's clear.
Could you read this inside the rectangle red color? I have marked there. Could you